This is Unit 6, Preview Video 6.5, Coordinate Proofs. Take a moment, sit tall, and inhale. Hold. Exhale. Close your eyes for like 5 seconds. Deep breath. Open your eyes. Let's do this. Don't forget date, time, and location, friends. So you need to understand that math is a language. Math is a form of communication. Math is not designed simply to make your life difficult, horrible, challenging, whatever it is, but math communicates. All language communicates. Written language, spoken language, facial gestures and body language, all of that communicates something. Math also communicates physical and sometimes theoretical realities. So we're going to boil it down to the super basic meanings of math on a coordinate plane for at least geometry. The slope is a tilt concept. Slope, tilt. Physically do this. Slope, tilt. Tilt will show us if we have parallel lines where slope equals slope and perpendicular lines where slope times slope would equal -1. Unless it's horizontal and vertical, then it's 0 and undefined. So if I want to prove that this segment, the red and the blue segment, are perpendicular, I would find the slope of the blue, y minus y over x minus x. I'd find the slope of the red, y minus y, x minus x. And then if those slopes, slope times slope, multiplied to -1, the meaning of that math would be, behold, they're perpendicular, therefore it's a right angle. Math, meaning, punchline. The math would be, here's the slope of the blue line and the red line, they multiply to -1. Meaning, the lines are perpendicular. Finally, punchline, therefore there's a right angle. Math, meaning, punchline. Taking a look here, the midpoint equation will show if something's bisected or has a common midpoint. So if I have a segment here that goes through the red, excuse me, I said segment, not line, at a certain point, and I'm asking myself, is it being bisected? I would find the midpoint of the red, which is add the x's, divide by 2, add the y's, divide by 2. And if this coordinate matched that point at which the segment goes through, then I have proven, behold, here's the math, this coordinate, its meaning, therefore, that's a midpoint. Punchline, this segment is bisecting the red segment. Math, meaning punchline. Do you see a theme here? Distance shows comparative lengths. It can show that two lengths are equal in measure or congruent. So if I have this segment here, the red, let's say I have another segment and I want to show those segments are of equal length, then I would find the distance of the red using the distance equation, and I would find the distance of the blue using the distance equation. And then if my math shows that the distances are equal, then punchline, they are congruent. So the math would be, here's the distance of the red, square root whatever. Here's the distance of the blue, square root whatever. Meaning they are of equal measured length. Punchline, therefore they are congruent. Math meaning punchline. We're going to apply this to a parallelogram. So we have a shape here. We're given coordinates, and all we are given those coordinates. Always put the coordinates directly on. And we want to prove mathematically it is a parallelogram. There are 5 ways to prove 5 qualities of a parallelogram. OCD. All you have to do is prove one of those 5. So we're going to prove OCD. We're going to prove it's a parallelogram using the first one, which is opposite sides parallel. So you ask yourself, what would prove parallel? It would be like this. We're going to find the slope of, let me get some colors here so it's easy, AB. I'm going to just set everything up so it goes faster. And DC. And then I'm going to find the slope of AD. And the slope of B to C. Y minus Y over X minus X. Notice I physically connect the numbers. Now you simply do your math. You do your own. So the top are both negative 1/2. And both bottoms are also negative 7/3. Congratulations. We have proven it's a parallelogram. Now your write-up would look something like this. Math meaning punchline. Doesn't have to be long, but I expect all 3 components. Math. Here's your first sentence. Math. You actually recite the math. There you go. I got all the slopes. Meaning, so AB is parallel to DC. AD is parallel to BC because slope equals slope. Punchline. Finally, it is a parallelogram because opposite sides are parallel. Math, meaning, punchline. Same thing here. This one, we're going to show, remember there's 5 qualities, OCD. And this one we're going to prove it's a parallelogram by showing the diagonals bisect, which would be the D. Same diagram. We're going to draw in the diagonals. Corner to corner, AC. Corner to corner, BD. So we're going to find midpoint AC. Set it up, add the x's, divide by 2, add the y's, divide by 2. Midpoint BD, add the x's, divide by 2, add the y's, divide by 2. So we pop in our x's. -1, 6. 5, -4, pop in your x's, 3 and 2, 3 and -2. My coordinate here, that's going to be 4. That's going to be 5/2. And this is 1/2. This is 5/2. And 1/2. I'm going to change the 5/2 to 2.5 so it's easier to graph. So let's look. Midpoint does match both ways. If you watch, over 2, up 1/2. So that's 2.5 and 1/2, and it matches both ways. Ta-da! Well, you have proven that this bisects that way, and this bisects this way. Math, meaning, punchline. So we come down here. First sentence is the math. There's your math, both ways. That's that's AC and BD. BD. AC was the blue. I'll color code it for you. And BD was the green. There's your math. Meaning of the math. So AC bisects BD and BD bisects AC. Punchline. So finally, ABCD is a parallelogram because diagonals bisect each other. Math, meaning, punchline. This page, you're going to do on your own. Make sure you read the instructions. Pause the video, do your own work. Pause. Welcome back. Let's see what your instructions were. Your instructions were to prove it's a parallelogram, but you were supposed to prove it by showing opposite sides were congruent in length by using the distance equation. So you would have here the distance of AB. Let's set the template up. So these are the distances you should have gotten: root 20, root 20, root 58, root 58, and then you do the math, meaning punchline. Math. There's your math. What is the meaning of the math? So AB is congruent DC. AD is congruent BC. Punchline. Finally, ABCD is a parallelogram because opposite sides are congruent. Math, meaning, punchline. Gotta have all three. We're going to do one more together. We're going to get beyond parallelograms into rectangles, rhombi, and squares. Oh my. Math has meaning. So we are given a parallelogram, T, which is at 0, 10, U, 4, 2, N, negative 2, negative 1, and E, negative 6, comma 7. And this is called a double proof, a positive and a negative. Positive, we want to prove it's a rectangle. Negative, we want to disprove mathematically that it is a square. Prove it's a rectangle, but mathematically disprove it's a square. There's several ways to do this. So first you ask yourself, what makes a rectangle a rectangle? Well, one would be a rectangle has congruent length diagonals. So the blue and the red would be congruent in length, where in a parallelogram, you have a shorter and a longer one. The green is longer, the black is shorter. So that is one quality in a rectangle, congruent length diagonals. You ask yourself, how could you prove that or show it mathematically? And if it's a length concept, you would use the distance equation. And of course, by definition, a rectangle has right angles in the corners. Right angle corners. And how do you prove right angles? That's a slope concept because it's perpendicular. Next, we're going to differentiate between a square and a rectangle. Now, first you have to think about what makes them the same, because we're trying to avoid that. We're trying to differentiate. So what do they have in common? Well, they both have right angles in common, and they both have congruent length diagonals. The blue and the red will be congruent in length. So they have that in common. So you're like, well, how do you tell the difference? Qualities of a square, of course, is the fact that all four sides are congruent. And if we want to go that way, that would be a distance concept, because a rectangle only has opposite congruent sides. And what's different about a square is it has perpendicular diagonals in the middle. Perpendicular diagonals. How would you prove that? Slope. So for each one, I have two different methods. Totally okay to use one or the other, but for this video, I'm only doing one of each. So to show it is a rectangle, we're going to go for right angle corners. And to disprove it's a square, we're going to show that the diagonals are not perpendicular. So step number one, we're going to show that there's a right angle in the corner. So we're going to take any two sides, doesn't matter which ones. So I'm going to find the slope of TU, y minus y over x minus x, and the slope of UN, y minus y, x minus x. Y is on top. So the slope of TU is going to be, that's 8 over negative 4. So I get negative 2 over 1. Down here, I'm getting 4. I did not physically circle plug chug, negative 2, negative 1, and it's just that easy, folks, to make mistakes if you don't circle, plug, chug, even as the teacher. So let me double check that. Y minus y, and circling, that's going to be 4, negative 2, much better. So this ends up being 3 over 6, which is positive 1/2. Notice I have just proven negative 2 over 1 times 1 over 2. That gets me negative 1. I have proven there's a right angle right there because they're perpendicular. Ready? T, U, N, E. Now, so we have proven it's a rectangle. Ta-da! You have a rectangle. Congratulations, you have a rectangle. Now we're going to disprove that it's a square by doing the diagonal TN and the diagonal EU. We're going to find the slope for both. Y minus y over x minus x. Physically circling the numbers. Y minus y. It's 10, negative 1. X minus x. 0, negative 2. Going this way. Y minus y. Physically connecting, 7, 2. And x minus x. Negative 6 and 4. Do the slope here. That's double negative makes a positive. So t to n, the slope is positive, which we expect. Left to right going up. 11 over 2. This one. 5 over negative 10, negative 1/2, which we'd expect going down, left to right. And notice slopes do not multiply to negative 1. That tells you something that is not happening in those diagonals. It cannot be a square because of that math. Now, what your job is, and I'm not writing this for you, is you are writing 3 sentences. In your sentence 1, you're going to cite your math. Sentence 2, what is the meaning of your math? What is your math? What is the meaning of your math? And punchline, which is the phrase I'm using for your conclusion. You write your own 3 sentences. And then summarize the entire math on your own. I'm not going to do this for you. Make sure you summarize the overall today's lesson as well.